Hello everyone, welcome to another video. In this video we are going to discuss a string limitation, or something that you need to be careful when working with strings, and how can you solve this limitation using StringBuilder. Okay, so oftentimes when you're working with strings you have something like this. Okay, you have an original string, or let's say str, and this string has some initial value. Okay, and during your work you have to do some kind of for loop. Okay, and then you have to append some value to a string during this loop. Okay, or you have to perform some string manipulation during some kind of looping. Okay, so or for example, you're reading from some API and that's streaming data to you. So whenever you get some kind of content from this stream of data, you append it to the already existing string. Okay, something like we have here. Okay, while this might seem inoffensive at first, this actually has an underlying issue. And the underlying issue is that strings, they are immutable in C#. Okay, which means that you cannot actually modify a string without creating a new one. So creating or mutating a string by default and behind the scenes generates a new string. Okay, which means that every mutation you do, you generate a new string, you generate a new string, and so on. You will generate as much strings as the number of mutations you have. If you have 10 mutations on a string, then you'll generate 10 different strings. Okay, assuming that every mutation generates a new string, of course, nevertheless, still going to generate multiple strings, except there's an exception, which is if you have 1000 strings with the same content. Actually, there is an optimization done which will point this reference to the same string actually. And that only happens because strings are immutable, and this process of having a single reference, even though you have multiple strings with different values, is called, I think it's called string interning. Okay, but you can check that out. That's nevertheless an interesting topic. Some optimizations that might happen behind the scenes. Okay, but regardless, strings are immutable, and every mutation on a string generates a new one. Okay, one of the reasons why is because strings behind the scenes, they are an array of characters. Okay, which means that by default the array itself is full with characters, so there is no actual space to add more characters. So a way to actually circumvent this issue is to copy the content of the current array to a new array and then add the values you have to add. Okay, so that might be one of the reasons why a new string is generated. It has to do with the string internals, how a string is represented behind the scenes. Okay, so if doing this is bad, if I'm adding and mutating strings in a loop, for example, then what's the alternative? Okay, so the alternative is to use StringBuilder. So a StringBuilder is a utility class that you use to help you create and mutate strings without having this issue of for whatever mutation you do, you generate a new string. Okay, so a StringBuilder class, so a utility class that helps you to do those string mutations more efficiently. Okay, and how can you do so? Well, you can create a StringBuilder. Okay, StringBuilder object coming from system text. Okay, And then whenever you want to append something to a string, you just do append hello. Okay, or even here, I believe you can have a default value, like a default string. Okay, and then if you want to see the content of StringBuilder, you do some kind of toString. Okay, and then if we run this, we should see the content of this StringBuilder. Okay, hello start hello. Okay, so StringBuilders, they, as I said, utility class that helps you to efficiently handle string mutations. Okay, and how much more efficient then can this string builder be when compared to a simple append like the one we are doing here? Okay, can be much more efficient. We'll do a benchmark in a minute. Okay, so starting with this benchmark, okay, we can create a public class string versus string builder benchmarks. Okay, benchmarks. Okay, and just by the way, just because string builder is more efficient than concatenating like this, that doesn't mean that string builder should be used everywhere. It shouldn't. For example, if you have just one mutation of your string, like a simple in-place mutation, maybe that's not worth it. All this over-engineering of creating an object like a string builder and then do the append, maybe that's not worth it. Okay, but nevertheless, we'll create a benchmark for it. Okay, so we have here our benchmark class, and let's create something that will represent the number of runs we will do. Okay, so num of let's call it number of concates. Okay, number of concatenations we will perform. Okay, now we will need to use benchmark.net. We don't have benchmark.net installed, so the NuGet package, so I advise you to do so. I'll do it via the console, so .net add package benchmark dot, I think it's .net, something like this. Okay, need to go inside the project, and inside this project install this package. Okay, so you'll need a NuGet package called benchmark.net, and this NuGet package will help you to manage these benchmarks. Okay, so yeah, so one of the things we will do on this benchmark is to analyze memory usage. So let's annotate this with this memory diagnoser, which comes from benchmark.net. And here, as I was saying, on the number of concats, we will start small. We will start with 1, and we'll do 10, 100, 1000, like this, 1000, and then let's say 10,000. Okay, 10,000. So this will run for this will do some loops here to set up. Okay, now we can also either create an items array where we will instantiate this items array with some predefined number of strings. I will add them while we are doing the test. Okay, just to avoid having this benchmark class bloat. Okay, so let me first create the simple baseline method, which is this one. Okay, the one that will serve as a reference method. Okay, so if I do public string plus concat. So this will actually correspond to this one here. Okay, I want to test this one. This will serve as our baseline, and it will start at 0 and then do whatever number of concats we have here, and then append this here to this string. Okay, and here this is a benchmark, and this is our baseline benchmark. Okay, so this will benchmark this scenario here. Okay, then of course this will start at 1, then at 10, 1000, and 10,000. Okay, then we can test the string builder case. Okay, so public string builder concatenation. We will start by instantiating string builder, then doing the same loop, but at the end append 1. Okay, so which is somewhat the equivalent of what we were doing here. Okay, and here again this is a benchmark. Okay, now benchmarks, they need to run somewhere, so we can create here our main class. Okay, that will run here this this thing here. Okay, so let me comment this out. This was what we've done before. Okay, and yeah, so this main method will run our benchmark. Okay, we can even make this simpler just by doing this and then importing this. Okay, so yeah, so just as a recap, we've created a benchmark. This benchmark has some number of iterations it will do, starting with 1, going all the way to 10,000. We are going to test specifically 2 scenarios. We could have tested more, but pretty much one is appending with plus equals, and one is appending with the string builder method. And we will see which one is the best performance-wise. Okay, we will run some benchmarks and effectively see which ones gives us the best results. Okay, so in order to run the benchmarks, we can do .NET run -c release. Okay, run this in the release brand under the release build, release configuration, and this will take a while. And once this is done, I'll be back here in the video, and yeah, we continue and analyze the results. Okay, so the benchmarks have finished, and now let's have a look at them. Okay, so let's start with the first case. Okay, where we have only one concatenation. Okay, the simple concatenation executed in 1 nanosecond. Okay, more or less, and allocated close to nothing. Okay, or in this case actually nothing. But the string builder actually was much slower and allocated some bytes. Okay, so as I said to you before, for very simple scenarios, there's no need to over-engineer our solution. Okay, and as you can see, almost 6 times with string builder for one concatenation. String builder is 6 times slower, almost 6 times slower. Okay, now the interesting fact comes when we start to do more concatenations. Okay, as you can see, string builder starts to gain some advantage and has not only less time in terms of execution, but it allocates also less memory. Okay, in terms of execution, it runs on half the time that the simple concatenation executes, and also allocates more or less half the memory. Okay, and now even more discrepancies. Okay, when the number of concatenations in 100, you can see that the execution time now is 4 times lower In StringBuilder, this means that the simple concatenation takes 4 times the time to execute. Okay, and in terms of allocation, it's much lower. Okay, what we allocate for the StringBuilder is in this case super low. Okay, and then again you can see the results as number of concats grow, comparing the execution of StringBuilder with plus concatenation. You cannot compare. Okay, StringBuilder is always in the cases where the number of concatenation grows, StringBuilder tends to be more performant. Okay, as you can see here, the ratio is crazy. Okay, also not only in terms of time but also in terms of allocations. Okay, so yeah, as you can see here, hopefully with this benchmarks, you could see that using StringBuilder as the number of concatenations grow is much more performant than using the simple concatenation. Okay, so this is something you need to be attentive about, because you can easily fall into this trap. Okay, so that's it for this video. I just wanted to raise some awareness for this issue. Hopefully you've enjoyed it. Thank you for watching, and I'll see you in the next one. Bye.